This segment is about solving the Hubble first principles equation to find the Hubble constant with real data. So first of all, this is the quadratic equation that we're going to use. This equation was derived in the segment coming up later called Solving HFP Equation, which you can see in your table of contents. And the key thing to note here is that the only raw data we need to solve for the Hubble constant is dl and the observed redshift. So it's quite straightforward to build a spreadsheet using the quadratic formula, and that's explained in the other video segment. So here's data that comes from the Hubble Space Telescope Key Project team to measure the Hubble constant, their final report. And I'll put the URL for that up in a moment. I just took data for some of the supernova. Here's the list. And they give the data for the supernova with the velocity, the distance, and their calculated Hubble constant for each supernova. In order to do my calculation, I had to calculate the redshift for each supernova because they didn't give it in their final report, and I didn't want to go digging for the data. So that's simply the velocity divided by the speed of light. Then, using the distance and the redshift in the quadratic equation, we solve for the Hubble constant. This is the solution for the positive square root, and here are the solutions for the negative square root. And you can see that the calculated Hubble values using the first principles approach are just about 1/2 of the calculated Hubble values using only the cosmological redshift approach. Now, this is only a very small sample for illustrative purposes. The HST Key Project team did some very sophisticated calculations in order to take all the raw data for individual objects and come up with a final total value for the Hubble constant. And each of the other project teams that have calculated values for the Hubble constant from their own data have also used very sophisticated computational methods to arrive at their final estimate of the Hubble constant. Now, one question you might be asking yourself is, why haven't physicists and cosmologists taken the Doppler redshift component into account in their past calculations? And I think the reason is that there's been a misperception, I believe, that the recessional velocity of the distant galaxy is only an apparent recessional velocity that doesn't have the effect of creating a Doppler redshift. But upon close examination, that view seems extremely questionable, and this was discussed in the segments Hubble07 and Hubble08. So here again is the URL where you can go get the 2001 final report from the Hubble Space Telescope Key Project team if you want to get some of the raw data from that report to run your own spreadsheet. And here are two other websites where you can get some data to play with. The first is my website, bigpond.com/npajic, NPAJKIC, and then download the the lab report. And the other is do a Google search on the words galaxy space CRBOR1, and then only a couple of things come up, and then download the data.